Good evening, sir.
How are you?
Fine, sir.
Fine. So, how your studies going?
Okay, sir. Not
Okay,
bad.
not bad. Nice. You're pure science or math bio? Or sorry, like a math student, right? Math
MPC, sir.
computer. Okay, fine. Super. That means you're giving JEE exam. So your target will be January, right?
Yes, sir.
Super. So today, anyhow, I'm going to start new chapter, new topic in the sense.
Okay, sir.
We'll wait for a few minutes. Let them join.
Yeah, sure, sir.
Okay, what are chapters you're thorough with? Yeah. What are chapters you know like very well? Like this chapters, I'm okay with that. This topic, I'm okay with that. What are topics you know nicely? Yeah.
What, sir?
What are topics? What are chapters you know perfectly?
No, sir.
No, like you might have some confidence in this chapter. Okay, this chapters I am okay with that. Some chapter,
Magnetism and matter, sir.
magnetism and matters. Okay. Any topic from your 11th standard portion?
Sir?
Any topic from your 11th portion? No. Okay. No problem. Hello, Aditi.
Hello, sir.
All good.
So your voice was breaking.
I think my voice is breaking somewhat.
Yeah,
Is my voice breaking?
kind of.
Kind of. Okay. Chalo, let's start. Enough waiting for them. Let them join later. Aditi, finally your wait is over. Yeah, we are going to start your favorite topic,
Which one, sir?
thermodynamics.
Oh, cool.
You're waiting for this topic since long, na?
Actually, I wanted to complete the 11th portion as soon as possible, like because it's easier to revise. Like I'm having a lot of holidays
Yeah,
nowadays, Dashera, and then we'll have Christmas.
yeah, but I told you, right? Yeah, then actually we have more time, but I told you, right? Like my first target is to make them clear this 12 people. Let them
Yeah,
clear this. first JEE exam. They will clear nicely in January. Why it
No,
is
actually,
people are
I
not
kind of
doing?
find 11th physics a bit harder than the 12th one. So I just wanted to revise it again, during 12th me holidays or something like that.
Mhm. Okay. Okay, then let's start this thermodynamics. Thermo and dynamics. Thermo means heat. Dynamic means motion. Heat in motion. Simple term. Okay, so let's start with some basic laws for thermodynamics. For that, we need to know what is thermal equilibrium. And Janvi, whenever you have some doubt, you can ask me there itself. Okay, don't feel like should I ask or not, like that. Nothing to feel shy or something. Okay.
Okay, sir.
Or some explanation for that? Anything?
We have done this chapter in chemistry, and like in chemistry, thermal equilibrium is when the temperature is increased or decreased, it directly affects the equilibrium constant. And if it's a uh, exothermic reaction, the K value decreases, and if it's an endothermic reaction, temperature increases as well as K value increases.
Okay. Right, that is true. Okay, I want some very, very simple thing, like simplest possible thing. Not definition, nothing like that. Just one simple explanation. Can you make it simple now?
Okay, so when this temperature change, the system or the reaction tries to get back to equilibrium by either decreasing the temperature or increasing the temperature.
Yes, perfect. What about you? Janvi, what do you think? What is thermal equilibrium? No idea? Okay, chalo. See, if we go with simple terms, as she said, yes. Object which is in equilibrium condition. Object which is in equilibrium condition, like, okay, see, let's take one isolated object or isolated system. There I'm keeping one hot rod and another one which is cold. One hot rod, one cold rod. If I place in one isolated system, this heat will not transfer outside the wall and no outside heat is entering here. That is what isolation means. Now, this heat is transferred to this one, this cold object. Now, till when or till what amount that heat will be transferred? How much heat will be transferred? How to know that this much heat
Both of the like both A and B have equal temperature.
Yes, A and B may become equally. Like this will become a little bit colder and this will become a little bit hotter. So once they reach their common condition, that is your equilibrium state. So we can say this system is now thermally equilibrium. ठीक है? Easy?
Yes, sir.
Yes? Okay. Janvi, are you there?
Yes, sir.
Okay. You got it? Easy?
Yeah, sir.
Okay. So thermally equilibrium, let's try something about it. Um, like in this one, we can say like when macroscopic variables describing thermodynamic state of system, which is not depending on time. With this one, we understand zeroth law of thermodynamics. It is very, very simple. Zeroth law is very, if object there's a thermic.
So your voice is breaking.
Your voice, okay, my voice is breaking. I'm being like J, B are separated by thermal equilibrium with third object C. Then A and B are
The voice is not clear,
equilibrium
sir.
with
No, your voice is not audible, it's breaking.
am I audible now?
Yes, sir.
Array, my internet is not there. What happened? Mr. Internet. Okay, I was saying, yeah, when A and B are separated by thermal equilibrium with the third object. So we can say that A and B are in thermally equilibrium to each other. With each other. That is zeroth law. It's simple, like A and B are in thermal equilibrium with C. So we can say A and B are in thermal equilibrium with each other. It is very simple thing. Now for that, we need to know few things about thermodynamics. Before knowing this chapter, we should know some basic thing. What do you mean by system? System means,
It's a
what do you
part
mean by
of
system?
universe. It is a part of universe where an observation or a reaction takes place or are made.
Yeah, reaction take place, or we can make those. We can study about what? Pressure, temperature, and all that.
Yeah.
So this object and this is your surrounding. So together all this, it is called system. In that, what are the effect of temperature, pressure, volume to be noted?
So volume and pressure are inversely proportional, while temperature and pressure are directly proportional.
Directly proportional. Yes. So this three mainly, see, in this chapter, we are going to discuss only about pressure, volume, temperature, with some other variables, but mainly our concentration will be on these three. Both thermodynamics and kinetic theory, both will be studied this way.
So these the function or like the function of these three is directly related to Le-Chatelier's principle, right?
Yes. Okay. Now surrounding. What is surrounding?
It is everything other than the system.
Yes.
And
Correct.
system and surroundings together form universe.
Yeah. So we can say, let's make an example here. Some gas which is fitted inside the cylinder or piston. Fitted in piston. So this whole thing is called system. Gas and piston is called system. Okay. Now, outside the system is called surrounding. Example, you are sitting in the room. So if you consider, if you're observing from outside your house, this is your house, this is your table, you're sitting here. So I'm observing from here. So for me, this room, you and your table, including this all thing is here, is system. Outside the system, this is called surrounding. But if I'm inside the room, I can say you are the system. Remaining thing are surrounding for you. So this system and surrounding depends upon observer. Okay, don't get confused with system surrounding. This all are like objective place. It may vary. System and surrounding may vary from person to person or reference point. Okay, clear? Am I audible?
Yes, sir.
Okay. Now surrounding means anything outside system. In there, what energies exchange or whatever properties are changing, which happen, which in that, like everything will happen, like energy exchange and properties changes.
So is temperature directly proportional to volume or indirectly?
Indirectly. But actually, we cannot consider temperature and volume proportional.
But again, like
Temperature and pressure and pressure and volume.
so we should just consider pressure and volume. Like we can't relate
Yeah.
temperature and volume.
Yeah, we cannot. I think so. You asked me this question before also, right? I guess
No, sir.
might be someone else. Fine. Okay. So this system and surrounding, next is your thermodynamic state. Now thermodynamic state means simple thing like which has some composition, then temperature, then volume. That's right here. Which is some composition, then temperature, volume, pressure. So these four parameters we need to see here. We can say parameters or variable, whatever. I use their variable, I think so somewhere. So these are the variables or parameters or whatever you say. So for this thing, we should have one thing, that is system should be some homogeneous. So if the system is homogeneous, then all this composition will be like stable, or we can say we can everything describe in proper way, like PV equals to nRT. Okay. So these are three variables: PV, nR, and T, temperature. So for system is homogeneous. Homogeneous and has some definite shape, mass, and composition. So if it is in homogeneous and has definite mass and composition, we can describe the system in PV equals to nRT. So for this thermodynamic state, we need to have some two more terms. That is adiabatic wall and another one dithermic wall. Now adiabatic means simply insulated.
Non-conducting.
Yeah. Non-conducting or insulated. And insulating wall. See, this doesn't insulating wall, it doesn't mean it is not movable. It can be movable, okay? It can be movable, cannot be movable, depends. So insulating wall, that means what? It does not allow flow of energy. Energy in the sense heat energy, okay? Specific heat energy. Let me write here. From one side to another. Dithermic. So dithermic means
Conducting.
same.
Walls.
Exactly. Instead of all this, it does allow. This is conducting, this is non-conducting. Simple. Clear with all this chota basic? Any question?
So you can give example for imaginary boundaries.
Imaginary boundaries means like outside the surface, anywhere it can be. In air, those are imaginary boundaries.
But like, how does it works? Like, if it is air, then it should be a real boundary, right? Because it basically it does exist.
It does exist. Okay,
then
fine.
it should come under real boundaries, right?
Yeah, that is real boundary as well as imaginary ones, because we cannot make a boundary for air.
Okay, so basically it doesn't have a definite shape or
Exactly.
it doesn't
So
have
we
a
cannot
definite shape and like we can't see it or anything like how it works. So call it as an imaginary boundary, even if it does exist.
exactly. That is what my point is here.
So we can also call
So
water or like, a flowing water body as imaginary boundary, like if its
uh,
reaction is happening in the center of the water body.
see, exactly, we cannot say water as like imaginary boundaries because water do have some shape.
No, I mean like a flowing water body, which is continuously flowing. So it doesn't have a definite shape, right?
Even stagnant water also doesn't have any shape.
But it is like it occupies a particular area and it doesn't move, right?
Flowing water is moving, no?
Yeah, I'm talking about stagnant water. We can
Stagnant
call it
water, yeah.
as real, but flowing water, like and or air, both of them
Yeah,
like they are not sitting or like they're not resting at a
they're
place,
not. Yeah. So
continuously moving. There's a cycle. So can we call them like so they are imaginary boundaries, while something like stagnant water or a oxygen tank or something like that is real. Like
real boundary.
it's not moving, but we know like the volume or the space they're taking up.
Okay. Yeah. Yeah. That we can consider that. You're thinking this much? Nice. Okay. Anything else?
No, sir. As
Any
we
other
go
doubt?
topic, we'll go in the topic. I'll remember something. I'll ask you again.
Yeah, no problem. That's questions are always welcome. Yes, Janvi, any doubt?
No, sir.
What about Sohan?
No, sir.
What happened? Why did you join late, बच्चे?
सर खा रहा था सर
क्या हो गया?
खा रहा था सर
अच्छा, खाना खा रहे थे. सही है. कॉलेज से आके भूख लग गई.
हमेशा लगती है सर
Oh, yeah, of course. Food is first. But yeah, okay. I won't suggest that. But while taking class also, you can
ओके सर
but don't spend like 1 hour for that only. Like 5 minutes, you can finish. Whole
Yes,
class
sir.
means you are eating only means okay. I don't want that.
ओके
Okay,
सर
before that time up, let's finish this because we'll come next class. I think it's a chemistry only, maybe.
So what's the zeroth law of thermodynamics again?
It is simple. Like zeroth law means if object A and B are placed here with a C, so A and B are thermally equilibrium with each other.
If A and C are in equilibrium and B and C are in equilibrium, then we can say that A and B are in equilibrium.
Yeah, which is each other.
Oh, got it.
Like, or other way also we can say, like, if A and B are like separated by C. I erased it. If A and B are separated by C, then A and B are, and this is also thermal equilibrium. A and B are separated by C, which is in thermal equilibrium condition. So we can say A and B are also in thermal equilibrium.
So basically, we are first separating A and B with a adiabatic wall, but we have a diathermic wall between CA and CB,
C and B,
and then we are
yes,
exchanging the walls, so it will come,
yes,
right?
it will come as equilibrium condition. First law of first law of thermodynamics. Do anyone remember? No one?
Energy of a isolated system is constant.
Okay. So what was in chemistry?
This wasn't
In chemistry,
the
no,
first
little difference.
uh,
Only difference in chemistry.
like we used delta Q, delta U, delta W, and we took that delta Q is equal to delta U plus delta W, and then they kind of stated that energy of an isolated system is always constant, there is no change.
Yeah. So only difference will be sign. See, laws cannot be changed, but way of using that law may change.
I mean, like it's logical because it's an isolated system, so there's obviously no energy transfer in or out of the system towards the surroundings. So the energy remains constant as it is.
Yeah, that is true. See, in difference between chemistry and physics thermodynamics, that is, here we will consider work as our output. In general case, we will use work as an output at most of the cases. So main focus is on work. What is work done? What is energy given? What is heat exchange? Internal energy? Okay, the first law states that if certain quantity of heat, that is dq, is added to a system, a part of it is used in increasing internal energy, that is du, and part of it is used or is used to perform external work, that is dw. So dq equals to du plus dw, or if you want du as a subject, du equals to dq minus dw. See, in this one is path independent. Now, what do you mean by path independent? What do you mean by path independent? Am I audible? Guys, can you hear me? Maybe my internet got slow. And they are?
Can it be like I just got
Good.
disconnected.
Oh, okay. What do you mean by path dependent or independent?
The path independent is like something which depends on the path that is going. It's not a state function, and path independent is a state function.
Yeah. So in this case, internal energy is path independent. But dw and dq, they both have some dependency on path. They are not path independent. They are path dependent. Okay, so we'll see remaining thing tomorrow about heat, work, internal energy, how does it work, what are the application of first law, and all blah 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 things. All graphs thing we will see that one by one. Okay, specific heat capacity, and all the other dramas. Have you done writing? Shall I stop sharing?
So
Is
1
anyone
minute.
writing? Oh yeah.
Yeah, sir.
Yes, anyone having doubt? Sohan?
No, sir. Actually, this thermodynamics is new, sir. In 11th, still haven't started thermodynamics.
Okay. What about Janvi?
No, sir.
It's Janvi or Jahanvi? How do
Jahnavi,
you
sir.
pronounce? Oh, my
Jahnavi.
bad. Oh, my bad, my bad.
Done, sir.
Done? Fine.
Yeah.
Okay, Pips, tomorrow. See you tomorrow. Bye-bye.
Thank you,
Bye.
sir. Bye, sir.
Yeah. Try to come early. Sohan?
Yes, sir. Bye.
Yeah. Bye-bye. And Madhusan also.